Welcome back. Today we are going to discuss a very important topic in IT industry, and this is also a very important interview question when it comes to DevOps. So we have this concept called mutability versus immutability in the IT world. So this particular concept is there in both software engineering and DevOps. In software engineering, the concept is applied in object-oriented programming, and in DevOps, it is applied to the infrastructure automation. Today, we are going to focus on immutable infrastructure from a DevOps standpoint. So before we get into the comparison and the pros and cons around immutability versus mutability, we'll just understand the definition and meaning of what is mutable and immutable. So from the name, mutable means it is changeable or it is customizable. So something that can be changed, mutate, or to change, to customize. That is what we call it as mutable. Mutable infrastructure is IT server infrastructure that is capable of being modified and updated in place on a regular basis. So we can go and do the customization, we can go and do an in-place upgrade or update, tweaking. Continuously, we can update, tweak, and tune the environment to meet a particular purpose. So to mutate is nothing but it is changeable. And the opposite is immutable, something that cannot be changed. So definition of immutable, not capable or susceptible to change. So immutable infrastructure is an IT infrastructure that's once deployed cannot be modified. So this is actually associated with both software engineering practice, both DevOps and continuous delivery. If changes or updates need to be made, an entirely new instance will be deployed with all the proper modification. So let's understand. See, even in the real world example, if you take your house, there are certain things which are mutable. So you can go and change the color of the door, or you can change the door handles, you can give it a different look. But there are certain things like your wash basin or your floor tile, you have to completely replace it. So certain things are mutable, certain things are immutable. So same applies to IT industry, both in software engineering practice as well as in DevOps. So over the period, last 20-25 years, software practices has evolved, has changed a lot. So if you are planning to have a business application for a particular purpose, we used to have a monolithic application which will be delivered using a waterfall development model that takes three months to 6 months and even a year for certain larger business application. And when we have the application, we used to run it on a dedicated physical server. So 20 years back, we did not have the concept of virtualization. So we did not have containerization, but all the application used to run on a dedicated physical server, and also those physical server used to be in our own data center. But now if you think, things have evolved a lot in software development. Things are being developed using agile process and DevOps framework, and we have our application divided into small microservices. Each of the functionalities, features has been subdivided into microservices. All those are now deployed as a container. So if you're thinking about how we deploy the infrastructure, either it is deployed using an image as a virtual machine or a virtual server, or it is getting deployed as a container. Okay, and now we are completely renting the infrastructure from a public cloud provider. We are not buying, we are not investing on the infrastructure. If you go back in like 20-25 years back, complete difference on how the way we used to develop, deploy, and configure the application, right? So let's understand the comparison here. So the cloud deployment pattern, it's completely closely related to immutable infrastructure. So mutable infrastructure, it is capable of changing. We go and install the infrastructure, we deploy a server, we log into the server, we install all the tools, we configure the repository and then update them. We install the security related tools, agents, configure firewall. We do a lot of things after things are deployed. So this is configuration management. So we develop the application code, we deploy the server, and then finally, like, we get the application running. So it is a kind of server that will continuously get updated in place. We'll do the upgrade. So it used to be a physical in the traditional world. The legacy infrastructure physical servers will continue to be used for a longer duration. But now things have become a disposable infrastructure. So instead of develop, deploy, and configure, what we are currently doing is we are developing the application code. We are getting it configured in a image like a Docker image or a hash using Packer. We go and create the image with all the necessary operating system, kernel, hardening, and we deploy the application, and we go and deploy it on the uh, either a virtual machine or a kind of container. So things have changed. It is a complete new deployment pattern. Um, so if you look at here, earlier we used to go and in place upgrade or in place update the application on the same set of hardware. But now in immutable infrastructure, we go and deploy the newer version on a complete new set of systems. So which makes our system free from, it is like all the systems will be consistent. See, at times when we go and deploy the newer version on different hardware, different systems might behave different because some of the prerequisites might be missing, some of the hardware might have some difference in configuration. So different systems might end up with different configuration settings and the consistency might not be there. But here things are predictable. We have one single image that we are pushing to multiple systems. So the infrastructure is completely deployed onto a new system, new set of systems. So there are two different things. So one is provisioning the system and configuration management. So these are the two important concepts. And when it comes to DevOps, there is a lot of different tools in the industry. So when you talk about configuration management of an existing system, we use tools like Chef, Puppet, SaltStack, and Ansible. Ansible is one of the very popular tool in the recent past. And when it comes to provisioning the infrastructure, we use AWS or cloud native tools like CDK, CloudFormation, Microsoft Azure related tools like ARM templates, Bicep, and then we also have Google Deployment Manager. Here we have got a couple of very popular third-party tools like Terraform and Pulumi, which is used for provisioning. And if you look at here, the infrastructure is mutable infrastructure. When it comes to configuration management, we have an existing hardware. We go and change, customize based on our business application requirement, and we tune it. Whereas here, immutable concept is primarily aligned with provisioning of the infrastructure. Either we provision it from the scratch or we go and get them replaced based on the new version of the image that is available. So industry has got a lot of enhancements. So enterprises have migrated from a monolithic traditional application to a kind of microservices on container platform managed using Docker and Kubernetes now. So things have changed, things have evolved a lot. And when it comes to DevOps, they always have this comparison analogy like pets versus cattle. You know how the pets are being treated at home, right? So it will be like you have unique names for each of your pet, and then you do hand raising, you have all better nursing and all those things. So you keep all like safety precautions for them. Similarly, like in the legacy infrastructure, so the hardware, the physical hardware on your premises data center are considered as pets here in DevOps analogy. So you maintain them, you run it for 8 years, 10 years, and then you have to upgrade it in place, or you do a vertical scaling in the legacy infrastructure. Whereas the systems in the cloud, currently in the DevOps model, they are considered as cattle, just like how the cattle are being treated, right? So we go and give a quantity to the total number of cattle. We don't have a kind of specific names. So when they get ill, we go and replace them. We get another set of cattle to serve the purpose. Similarly here in the cloud, especially, the infrastructure has become very disposable. So you go and get them replaced whenever there is a problem. So you go and get them deployed from the scratch with the use of some scripts, templates, and images. So we are not going to deploy them from the scratch. Instead, we use the scripts, templates, and images to get the system up and running. So that's a very good analogy. Like when it comes to DevOps, people compare it with pets and cattle for mutable versus immutable infrastructure. So now let's understand the pros and cons of mutable versus immutable infrastructure. So here, when you go and use the immutable tools like Terraform, Spinnaker, Docker, and Kubernetes, so it has got a lot of benefits. Like when you go and deploy your system using images or templates or scripts, you have all those templates, images stored in a centralized version control system. So if you want to kind of roll back in case of any issues, it is very easy to track and roll back because of the version control that is available in immutable concept. And also you can go and have a consistent environment across different non-production and production systems. You can go and repeat the deployment. Every system will have the same consistency. It is easy to test, and you will not have a configuration drift between each and every system like how you have in Mutable. Because in Mutable, we go and create them from scratch. We go and configure them one by one. So there is a lot of configuration drift possibility. But here in Immutable, it is a kind of infrastructure that is getting deployed using template. So configuration drift is not a possibility there. And you have a very predictable state for your infrastructure because all the systems are deployed using the same template image, and you have a very good integration with DevOps and cloud computing when it comes to immutable. So here with mutable, so only biggest advantage that it has got is around the 0-day vulnerability handling. So if there is a vulnerability that has to be that has to be fixed on the same day, then mutable infrastructure or tools like Ansible, those tools can be used to deploy the hot fixes or to fix the bugs. It can be used very quickly. Okay, so provisioning time is it is like time consuming in the case of mutable, because in immutable we use the images and templates. If in case of any disaster in your data center, you just go and quickly redeploy them using those, whereas here you have to rebuild from the scratch. So that is the problem with mutable, but it has got advantage of how we handle the patching and how we push the iOS to your network devices and so on. So here there is a small cost overhead because you might have the existing environment and the new environment running at the same time for some quantifiable number of days. So during that time, you might have some cost overrun, but then with reducing the downtime, by avoiding the downtime, that cost can be handled. So let me give you an example. So to understand this better, so mutable infrastructure concept, you have a server, you have an instance with a particular operating system and an application. And if you have a newer version of an application, you go and install them in place. You go and update them, upgrade them on the same instance. And here, what we do in immutable concept, so you have an instance A with a particular operating system and an app version. So you destroy them and you recreate them with a kind of newer application version. So you might get a valid question, how you are managing the downtime here, how we can get the users redirected to the newer version of the application or the instance without downtime. That is where load balancing and auto scaling concepts come into play. So in mutable infrastructure, servers can be modified, customized manually. You can log into the server, make configuration changes, and you can do any installation, upgrade, or update, or whatever you want to do, you can do it. But in immutable concept, once the system is deployed, it cannot be modified. But you have to think these things at the application level. So don't go and think how the hardware infrastructure is being managed, right? So see, for example, even using tools like Terraform, you can go and modify the hardware configuration. You can upgrade the CPU or memory and all those stuffs without changing the instance name or instance ID, or without even touching that, because like those changes at the hardware level, it is not going to impact anything of your application. So Terraform can make modifications at the hardware configuration level in a kind of mutable concept. So don't get confused with that. Think about the application layer and then how this is being handled in mutable versus immutable concept. So I'll give you clarity on how the users will get redirected to the newer version of the application. because like we are destroying the existing server and we are creating a new system here. So let's understand an example for Mutable also. See, when it comes to we are still using Ansible, right? So why Ansible is needed? I'll tell you a kind of quick use case here. So we have a application code, we have made ready a server with all the necessary stuffs, and then we go and deploy the application code on the server, which has got all the configuration settings, tools, utilities, and so on. But then these kind of configuration changes can be applied to a single server. What if you have multiple servers that needs to have a newer version of changes or configuration that needs to be applied? That is when Ansible kind of tools are very useful and comes handy. So you can go and push the newer iOS to multiple network devices, or you can go and apply the patches in hundreds of systems at the same time. So mutable infrastructure or mutable tools are still needed for making all the configuration changes. But what we are focusing now is about the immutability that is very popular in the cloud, especially in the DevOps framework. So here, instead of developing the code and then deploying the server and then configuring it, we get the code, or we get the code added to your custom image. So we add the code onto your custom image. We also do all the different OS installation, packaging and stuff using tools like Packer or Docker. And then we get those images deployed onto the server. So this has got interchanged with immutable and mutable concept. In immutable concept, we do all the configurations, we create the image before it gets deployed. Whereas in mutable concept, we deploy the server and we go and make all the changes on the system. So that is how these two tools are different. So now, after we have two systems running in parallel, so users will get redirected to the newer system, which is running with the newer version of the application, and we will phase the old system out. So while doing this, there are two different type of deployments that can be approached. So first deployment model is called blue-green deployment model. So here what we do is we have a set of systems that are running currently, and then we have a new set of systems that that are getting added. Okay, so what we will do is we'll go and uh, load balance the user's request to both the systems, and we will bring down the system that is getting decommissioned, and all the new requests will be redirected to the instance which has got all the latest version and latest features and settings. So this is called blue-green deployment model, and this is canary deployment. Canary deployment is a kind of phased rollout of the systems. So we'll have few users using the newer code version, and then we'll have most users using the majority infrastructure, and then gradually they will move from the older set of systems to the newer set of systems. This is phased rollout. So both of them have some advantages. So when it comes to Canary, only a subset of users will be migrated to the newer servers, and gradually they will increase the um, uh, request to the newer systems over the time actually. So that's how they completely switch over to the new systems. So load balancer will take care of redirecting the systems which are healthy, and it will we can start removing the systems. So these two deployment approach can completely eradicate the downtime. So that is how we manage the immutable infrastructure without any downtime to the end users. So we gradually migrate the end user load to the set of new systems that are getting deployed. Okay, so this is what I thought of covering. Thank you for listening. And in the next session, we will discuss about tools like Terraform versus Ansible, and we'll compare it between each other. Thank you.